MAT video. This time we'll do question 1J from MAT 2008. The question asks from 0 to 2 pi, how many solutions does this have? First, we'll work out periods. For odd powers, this should be easy. This should be of period. So this would be of period 2 pi. However, this period here is of period pi. So now let's draw this out. So we have 4. Since the largest one is 2, now we're going to draw from 2 pi. Since this is period pi, we can draw it, and this is a really large power sine 8, we can just draw it this way. Like cycloid. If you draw sine x, it will look a bit like sine, but squished a bit. Now how about 3 plus cos x squared? We can draw 16 up here, then 16. Hey, would you look at that? It only crosses the graph at one point, and it's at pi. The y value is 4. Hence, this has only one solution. Speaking of trigonometry, let's just go through the main trigonometric functions and some you never ever heard of. Like, you know, sine, cosine, tangent, cosecant, secant, and cotangent. Well, there are a few more that you might not know, like versine, cosine, covasine, and covacosine. So I cannot remember the expansion for each of them, but you can have half version, which is basically all of them times half, and then you will have x secant and x cosecant. Really interesting, this menagerie of trigonometric functions. And you can even develop these trigonometric functions out exponentials. You know Euler's formula, e to the I pi plus 1 is 0. Then you will definitely know what exponential to the power of imaginary powers is like. So a real exponent exhibits exponential growth. However, when you put an imaginary exponent to it, it actually goes through period 2 pi, and you can imagine it as kind of like a particle rolling around the circle anti-clockwise starting at the east axis. And if that madness isn't enough, sine x is e to the I pi, e to I theta, sine theta is e to I theta minus e to the power negative I theta over 2i. Cos theta equals to e to the I theta plus e to the power negative I theta over 2. Look familiar? If you know about hyperbolic functions, these definitions will look strangely familiar to you. Take out the i's and you get shine and cosh. Yeah, like more like cosine or something. Anyway, I bet you will enjoy making lots of other special functions from exponentials, and I hope you enjoy playing with these trigonometric functions. Goodbye!